Here we go. Question 1. This is a lesson. Actually, this will be 3 examples on how to solve a system of linear, almost, inequalities. Right? The solution is you graph it and you work it out. Whatever you shade, that is the solution. What do you mean? I fixed it. I know how to spell it. Okay, so solve a system of linear equations. A system means there's more than one, right? We got to find the solution. Ready for question 1? Okay. And that's not a system, right? No. Only one of them. -6. How about 1? Okay. Just to help, I'll do this one with blue, and I'll do this one with red. Oh, you want to do 3? Yeah. You're crazy. Maybe the next one. All right. Solve the system of linear inequalities. Basically, what this means is you have to graph each one individually on the same coordinate plane. In the overlapped shaded area is the solution. Okay, so these are already both in slope-intercept form. Okay. Guys working hard on this? Good.
Oh, we did a third one?
Whoops. No, there's no third one. I just wrote slope-intercept form up there. Okay. Hey, Cynthia, I have a question for you. What's the y-intercept on the blue one? What's the y-intercept of the blue? 2. Very good. Okay. It's the y-axis. 1, 2. Okay. Tay, what's the slope of the blue? Sorry? What? The blue. What's the slope of the blue? Which one's the slope? 3 over 5? The opposite of that. Okay, good. All right, so you got the y-intercept is 2. Now we're going to use the slope. Rise -3, which is down 3. Run 5. Go to the right 5. So from here, we're going to go down 3 and over 5. 1, 2, 3. 1, 2, 3, 4, 5. Be somewhere in here, right? Now, all you need is those 2 points to make the line. So we're ready to make the line, but before we do this, because we have an inequality, we have to decide, is the line a solid line or is it a dotted line? Dashed. It's dashed. Okay, the rule is if you have either of these, it's dashed. This and this is solid, right? Okay, so. Okay, so there's the blue line, right? I'm not going to shade it yet, though. I'm going to wait till I do the red one, then I'll shade them at the same time. All right. Shh. It's time to graph the red. All right. I need absolute silence. Brandy, what's the y-intercept of the red? Good. There we go. Shh. Casillas, what is the slope of the red? Good. So we're going to go up 1, right 1 from here. Up 1, right 1. Put us here. There's our 2 points. Now, this is the rule. Dotted or solid? The red. Look, it's equal. It's solid. Okay. Okay, so here's our 2 lines. Now we have to do the shading. With the blue, do we shade above or below the blue? Below? Y is less than, right? Less than, we shade below. The red, we shade above. So we got to figure out, where is it above the red and below the blue? Good, to the left. Over here, that's above the red and below the blue. So any point in this area is a solution. Okay? That's how you just did that. These are all the solutions in here, right? So for example, this point over here, not a solution. Would that be like 1, 2, 3, like 5, 2, not a solution. But point over here, say like for example, -4, 0, solution. Yeah, solution. Okay? Any questions? Okay, let's do number 2.
4.
Ready? Oh, whoops.
Do 4.
You want to do 3 equations at one time?
No, 4.
You guys are crazy. All right, here we go.
What are you doing?
What are you doing?
Okay, we're doing 3 this time. Now, typically, the more inequalities you add to this, the smaller the shaded region is going to become. Okay? Keep that in mind. This region isn't going to be like the side of one of the x's. It'll be probably like boxed in with a little triangle shape. Before anybody gets too far, Anthony T. This is slightly tricky. What is the y-intercept of the blue?
0 green.
Good. Did you say green? That's the y-intercept, right? Okay, good. Reggie, what's the slope of the blue? What's the slope of the blue one? 2, yeah. 2 over 1. Rise 2, run 1. Right, there's our dots. Okay, Eric Q, is the blue one dashed or solid?
So hard.
You say dashed, are you sure?
Yeah.
How sure? Like 100% sure? Yeah, good. Okay. Now, I don't want to shade it yet, but I'm just going to write down next to that, would the blue one be shaded above or below? What do you think, Natalie?
Below.
Can't hear you.
Below. Below what?
Don't you mean below? Okay, the red one, x is less than 5. There's no y. This is a, what kind of line? A vertical line or a horizontal line? It's vertical. 1, 2, 3, 4, 5. And it's a solid, right? Oops. It's supposed to, ideally is perfectly straight up, right? Okay, so that red one, you can't really shade above or below. You can only shade left or right. Left A la izquierda. Or right. A la derecha. X is less than 5. Are the numbers less than 5 to the left or to the right? To the left. So so far we have below the blue, left of the red. The green. Peng, what's the y-intercept on the green? 1. Okay. Okay, Jesse, what's the slope on the green?
It's like on the top.
The slope of the green. Negative 3 over. Okay, so what two directions are we going to go? Yeah, down 3 and over to the right 4. So from the 1, we're going to go down 1, 2, 3, and over 1, 2, 3, 4. Here, there's our 2 points. We got to connect them with a dotted?
Dashed line.
You sure?
Yes.
What do you think, Jesse? Dashed or solid on the green?
Dash. I'll delete this one.
Does everybody think dashed, Tiny?
Yes.
For what?
What do you think?
Dash.
Oh my god, dash.
Good. Okay, now, Tiny. Using the correct voice. Above or below?
Above. I mean, do I have to say it like you?
Yes.
No, I don't want to.
Does anybody want to?
Above.
No. It's not above. That's below. Above is like in the clouds. Like, yeah. Above. Okay, so in this drawing, we have to find a section that's above the green, below the blue, and to the left of the red. Okay, that would be in here, right? That's satisfies all. That's above blue. Below blue, left of red, above green. So anything in here is a solution, right?
Yes.
Now, here's a hey, it's the very last thing. Ready? Is that a solution right there?
Yes.
You guys see that point right there? Is that a solution?
Yes.
Yes. Right?
Yes.
Hold on. Shh. Hey, close attention. Anything in the shaded is a solution, right?
Yes.
Is that a solution?
Yes.
Yes. Is that a solution? No. Now, how about this one?
How about that one?
Is that a solution on the red line?
Yes.
Yes. Is this a solution on the green line?
Yes.
What about right here? Is that a solution?
Yes.
No. No for that one, yes for that one. The reason why it's a solid line is because if it's on the line, that's part of the solution.
If it's dashed, not.
If it's dashed, it's not part of the solution, it's just the barrier. Okay?
Got it.
You get it?
Yeah.
Okay. Alright, this is graphing, solving systems of linear inequalities. Any questions?
No.
Okay.